The ICMP is used for diagnostic purposes, and it's widely available. Virtually every local network uses the protocol, and few people block its packets. Even administrators rarely analyze these packets. Network intrusion detection systems discern the ICMP packets but don't analyze their contents. As you can see in the picture above, you can send data in ICMP packets. If you were connected to the network and wanted to send something so that the administrator wouldn't notice, you could use the ICMP packets for that. No one and nothing would block this data or analyze the contents of the packets you sent. This is because nobody expects any data in these packets. Usually there is none. On the web, you can find about a dozen programs that allow you to send text or binary codes using ICMP. How then can you secure yourself against vulnerabilities in the third layer of the OSI model? One of the solutions consists of dividing the network into smaller segments called subnets. We'll elaborate on that later on. Another is monitoring all packets passing through the layer. To ensure that no packets are sent or received without your control, you have to monitor IP and ICMP packets. The third method of protection involves taking into account that IP version 6 is a dynamic protocol. If you don't need automatic routing configuration, for example, you don't switch servers between networks, you should either disable it or limit it. You should also limit the list of IP addresses of routers you'll accept advertisements from. The network layer is the first layer of the OSI model that can be secured using protocols. In this layer, you can see the IPsec protocol. Because it works in the third layer, it's less visible for applications working in the seventh layer. We'll discuss the IPsec rules during one of the next lectures. Now we'll demonstrate how to impersonate somebody by changing your IP address and how easy it is to disable a computer by advertising false IP version 6 routes. We'll also learn how easy it is to perform IP spoofing in order to hide the IP of the computer used for remote scanning. We'll use the Nmap program. This is a tool that allows you to perform various types of scanning, such as TCP scanning and IP protocol scanning, which will be discussed later. It can also be used for IP and MAC spoofing. IP version 6 scanning can also be performed. First, we'll hide the real MAC address. We'll change it to a random address chosen from, for example, the pool of addresses of Apple network cards. Then we'll hide the real IP address. We'll use IP addresses which will be interpreted by the victim as computers that try to establish connections with it. To make it convincing, we must use only the addresses of computers currently online. At the moment, we're sure that the computer identified by IP number 192.168.0.115 is online. We can also use Nmap to generate a number of random addresses to use. We have to type the real address in as well. If all packets had false addresses in the sender IP address field, we wouldn't get a response from the victim's computer we were trying to perform the scan on. As a result, we would learn nothing about it. If the real address comes 6th or 7th, most network intrusion detection systems won't save it. For efficiency reasons, these systems usually only save the first 5 addresses. We choose the scan type, for example, TCP stealth scan. Also, we have to select the port we would like to scan. We choose standard TCP ports ranging from 1 to 1024. The last thing we have to do is determine the scan target. In a later part of the seminar, we'll learn how to monitor data passing through the network using Wireshark Network Analyzer. I highly recommend you return to this exercise once you get to know the program. With Wireshark enabled on the server you perform the scan on, you'll be able to see which sender IPs show up on the computer being scanned. It'll turn out that there's more than one, 6 for example. Only the 6th IP will identify the computer that actually performed the scan. Because only a sixth of the packets sent returned to us, the scan will take longer. When it's finished, we should be able to observe TCP ports on the target host ranging from 1 to 1024 are open. Let's have a closer look at one of the tools that are included in Backtrack. We can see here a couple of tools that send IP version 6 router advertisements. One of these tools is called Floyd Router 6. The only thing we have to provide in the program is the interface through which the advertisements need to be sent. Before you execute the command you see in the picture, it's advisable that you save all the documents you're working on, because it will crash all the local network hosts that support IP version 6 protocol. All of the computers that will be affected are running under Vista and Windows 7. We analyzed the first 3 layers of the OSI model: the physical layer, the data link layer, and the network layer. We also learned about the vulnerabilities characteristic of each layer and the ways to mitigate those vulnerabilities, which is the topic we will also elaborate on during the next modules. Thank you for your attention.